All right, hello. This is a video for non-technical and technical users. Nice to see y'all again. Hopefully y'all seen that deck type model video that kind of went over the deck type modeling and the predictions and all that. And with that out the way, this is now the final video to go for my Word League analysis notebook. All right, so I just went over recording all those technical videos, going down everything I did to get this data together from Excel sheets to the Discord, and then I got all that data together, and then I've created this scrape replay pipeline where I've used Bright Data to pull in that replay JSON from the DC Dueling Book replays, and I pulled that, I put it to S3 to store all those replay JSONs. And then I have to pull that back in. I have to parse. I have to make a deck type model, right? So that I could, predict deck types with the cards to eventually parse the replay JSONs to give me a database or give me a data table that could tell me for each game what cards did the player seen, what players were in each game, what was the result of the games, who went first, right? All the information from the replay JSON I have to create a parser for to deal with. And now we're here, right? Now we're finally here. So all the data is parsed, all the data is scraped. We have our games data table, and now we're prepared to do some analysis with it. So let's get started here. Okay, so go for my word league analysis, right? I have this huge ass table of contents. I'm going to first kind of go over the table of contents here. So number one, some disclaimers, then some setups with the imports and querying the data from our database. Then we have our data preparation steps. So we're going to do some cleaning. We're going to create a cards data frame here that we'll be using throughout this notebook. Then we're going to do some feature engineering. So this feature engineering step is going to be useful, number one, for analyses, this side type feature to define whether or not a game was pre-side or post-side. But we also have a deck partial feature column. And this will be useful for this following step here, to define the other deck type. So again, hopefully y'all saw the deck type model video. But in that, I've neglected to handle how we're going to deal with the other deck type. And that's going to be very dependent on some stuff. First and foremost is this parse data that I've collected from all Go For My Word League games. What does that data actually look like? What would the threshold be for my model's confidence and for the partial level of those decks, aka how much cards we're seeing in the deck? I'm not going to see 100% of the decks in replays, right? I might see like 20, 40, 60%, right? So, of those features, how can I find a good threshold for what I would define as utter? And this is especially important because now we're going to be seeing deck types that my model was not trained on, right? So we're going to be seeing some unknown deck types. So we're going to have to go into our data that we've just parsed out from the replays, and we're going to just go over that. I have a process for that. And we're going to define what an acceptable utter threshold would be given these features. Cool. So now we have our feet. Now we have our utter deck type defined and made and all that. Then we're gonna get into some EDA or exploratory data analysis. We're gonna do some general stuff first. We're gonna count, the match in game, some cool to know shit. Deck type match count, across seasons. That's the cool thing too, right? Because we have all this information. We have game numbers, cards, players, all that. But we also have it throughout time, right? Throughout seasons. So we're gonna be doing some analysis, not just in aggregate, but also over time. Then we have win rate calculations. This is gonna be a big one. Okay. We're gonna be talking about some different ways that people could calculate win rates given what's the good term here? Like imbalances in sample sizes. Okay. So we could, remove sample sizes. I'm gonna talk about Laplace smoothing here. Talk about the Wilson score interval, Bayes estimation, and then ultimately I have a thing that we'll use for our win rate calculations. And the goal here is to deal, because y'all probably seen it before, right? Like if y'all look at let me pull it up actually. So you come over here and we go to yu-gi-oh-scope.com, right? I'm not sure if it's up anymore. This place, I don't think it's being updated anymore. But yeah. So y'all probably seen it before, right? Like you have this, and you try to sort by win loss. Let's go to match cards actually. So in cards, you try to do this. What the hell? All right. All right. Say less. All right, cool, cool. All right, well, anyways, what would usually happen is that you try to do this sort like this, and you can still kind of see the effect here, right? Where if I sort for the lowest and I see zeros, I mean, zero win total losses is kind of crazy, you know what I'm saying? But sometimes, 0.5, 0.9, it's a lot different from, let's see here, try to get something in the middle here. Something that has like a good sample of a few hundred, let's say. And then likewise, you try to filter down. The highest win right here is this card here, 5 wins, 1 losses, but 83%, right? It kind of lowers the value of sorting by win rate because the tails is just going to be so influenced by the sample, right? This low sample. So the goal of the win rate adjustment that we're going to be doing is just to make it so that whenever I sort by win rate, the order of the cards would be more true. We want to get kind of close to what the true win rate would actually be if it was a higher sample. And the alternative is obviously just to filter it out. But we'll talk about that when we get there, because I talk about it in more detail once we get there. Then we're going to do some more EDA here. So deck type match win rate, non-mirror, most lopsided matchups, matchup matrix, most improved matchups across seasons, deck type game win rate, card game win rate. And then we're going to focus on one deck class here, Chaos Turbo. So I'm going to look at Chaos Turbo, and we're going to find out, we're going to answer some questions here, right? Best and worst matchups, matchups pre-side, post-side, best and worst cards pre-side, post-side. And then I'm also going to look at specifically the Warrior matchup. I want to go through all this shit, all right? And that's kind of the table of contents. That's how this is going to go down, all right? All right, cool. Let's get started then. I'm going to pull up the Zen. We'll keep it going. So some disclaimers. If you haven't been following along with all the videos here, you might not know about all the assumptions, all the biases, all the things that went on with our data set, what it is, what's going on. So this is kind of tries to, at a surface level, explain some things like that. So first and foremost, these games are from the Go format War League. Don't know what that is? That is a War League Go format. It has a server. They do these things every season. Where they have these wars, these brackets, all that. Cool. So this is from the Go format War League, not nowhere else. And the other thing about Go format War League, when it comes to this data and comes to this analysis, is that a team, is 5x5. So a team would have preparation for another team. So you might see things in a deck that you wouldn't usually see in a tournament. So if someone tries to extrapolate the findings from this notebook into like tournament settings, you gotta take it with a grain of salt, because you might see some Chaos Turbo decks with main deck Warrior Haste and pre-siding, right? You might see a lot more pre-siding. That's basically what I'm saying. You might see a lot of decks not respecting some matchups as much as it would in a tournament setting. Okay. So these games are from the Go format War League. It only has seasons 1 through 6, 6 being the most recent. And these are in-season games. What that means is that there's no playoff games. All right, there's no wildcard games. All right, only in-season games. So no playoffs or other tournaments as well, like the birthday bash and shit like that. Okay. All right, next one. This doesn't include games from matches with multiple replays. So sometimes the Go for War League would have one match, but it's across multiple replays. Say someone is in a match, they just finished game 1 and they disconnected, right? They disconnected. Now they have to do another replay. Oh, now they have to do the rest of the games. But now that one game is across 2 matches. In those cases, I didn't even add them. All right, it's just too much of a hassle. And so anything where one match is across multiple replays, I not included it here. All right, next one. Doesn't include the first 2 matches from season 6. So I don't think I even mentioned it in my Discord league data pipeline video, but there was 2 matches at the start of season 6 that I didn't parse because there's different versions of embedding that the Go for My War League bot did, and there's 3 of them, and the later 2 was the majority, which I've created parsers for, but the first one only had 2 samples, which was the first 2 matches, and it was just such hassle to kind of deal with that I didn't even include it, so I just skipped it. So the first 2 matches from season 6, I didn't even add it. All right. All data are extracted from replays. Okay. So players are defined from their dueling book names. A deck type model is used to predict deck types based on cards seen. So what that means is that I'm not using data aside from their URL from the Go for My War League. I'm not using the sheets. I'm not using deck history usage sheets. I'm not using any of that. My source of truth, all data is from the replays. Cards seen, games count, the player names, and based on the card scenes in that replay, I built a deck type model, which hopefully y'all have seen, to predict the deck type of based on the card seen. All right. So all data are extracted from the replays. This does not include. So this does not mean that like because currently in season 6 there's a World League bot, right? And in that World League bot, a lot of the analysis that they do there is based on the decks themselves, right? And the difference between that and looking at cards seen in the replay is that there will be analyses of a card in the Go for My World League bot that a person might not have even seen in a match, right? So that's not the case here. If a card is here, it's been seen. It's been an impact, stuff like that. So all cards are from what we're seeing in the replay. And what seen means is shit that is like, if you've seen my replay parsed video, I think it was the video before this one. If you've seen that one, you would know in greater detail. Granted, it's technical, but cards seen are cards that were taken from deck. So cards that were drawn, milled, banished, anything that was seen, public knowledge, not even public, but anything that was removed from deck and in the logs is a card that was seen. So this might not mean that someone has drawn a card and that they can actually use it, right? This might mean that Fate got no man from your deck, right? It might mean shit like that. Cool. So this does not imply the card was played. All right. As mentioned, some matches are not included. So there are about 4,000 matches total across all 6 seasons. So you could assume that less than 20 were omitted. This less than 20 is a combination of matches that were across multiple replays. Those 2 matches that I didn't include from season 6, and there were some other issues that you could get more detail about in the Excel league data pipeline video. All right, where I scraped from the Excel sheet. But all issues like that were because of shout out whoever was responsible for, collecting data in the Excel and everything, manual work and all that, all that. But there's obviously some mistakes as well. So like some replay URLs that's supposed to be there wasn't there. Some replay URLs was duplicated or shown twice, and one match wasn't of the other. So I had to essentially after deduplicating that data, there would be a match without a replay, basically. So you could assume that there was pretty much less than 20 total cases where a match was not included in this data set because of similar reasons or of what I've already described. Cool. So those are the disclaimers. Now we're going to get to the setup. Just going to import some libraries, basically. Now, again, I'm trying to make this video less technical as possible. So I'm not really going to go into much depth with the code and everything as in prior videos. So I'm going to kind of gloss over some of this stuff, right? So query the base data. This is just getting the data from my database to here. So what that actually looks like, if you look at the database here, in this games table, we've just populated this games table with the parsed replays in that last video that I just recorded. So in that run parse replay pipeline, the output of that parsed games is here, right? This is the table that we're querying from. This is what it looks like. Okay, so this is what the data looks like. We have player 1, player 2. We got the player 1's deck type, which our model predicted, right? So our model predicted this deck type for Nice Boy in this game 1. And my model had a 97% confidence in that prediction. Likewise for Ali. My model predicted Chaos Warrior. And it was this much confidence in that. And then here are the cards that Nice Boy have seen in that game 1 as a list of dictionaries. Matter of fact, sorry about saying that. This is the cards that person have seen. And these are the cards that Ali have seen as well for game 1. Then here's the game numbers, right? Game 1, game 2. Then the game winners for those games. Nice Boy, Nice Boy. And then whoever went first in that game. So, Nice Boy probably won the rock, paper, scissors, and he went first for this game. And then Alice won, went first the next game. Because they lost. All right. So this is what the data looks like. It is game by game data for all matches for all the World League games. All right. So that's how the structure and the schema and everything looks like. Okay. So I'm pulling in that data, and I'm also joining it with another table so we can get the replay URL as well. But this is kind of a snippet of what it looks like. Okay. So data preparation, don't mind this. Basically, this is just some good stuff to do. Okay, so some descriptive statistics of the data that we just put in. So we can see here, so these are the different columns in our data set. These are numeric columns from our data set. So you can see here in the season column, we have a minimum of 1 and a maximum of 6. Just to confirm that the seasons is from 1 to 6, okay? And the weeks, we have a minimum of 1 and a maximum of 15, okay? Player deck type confidence, okay? This is how confident our model was. This goes from 0 to 1, right? So we can see that the minimum was 11%. The maximum was, near 100%. Okay, likewise for player 2, deck type confidence, then game number. The minimum game number is 1, but a maximum of 5. So there was a match where someone have drawn twice. All right. All right, cool. So, just to kind of go over the descriptions here, make sure our data looks like it makes sense here. Seasons are between 1 to 6, weeks are between 1 to 15, model confidence are between 0 to 1, and the game numbers are greater than 1. All right, cool. Likewise, we're going to do the same thing for the deck types that my model has predicted. All right. So we see that the deck types, and again, very necessary, I think, that y'all should have seen the deck type model video, because we talk about the deck type model and all that, what to expect. So in that modeling, what my model knows and can predict are of what it was trained on. And it was trained on less than 30 deck types. So it's not all the deck types, all right? Like I know for a fact the empty jar wasn't there and heavy slump wasn't there, okay? So there's some deck types that weren't there. These are more obscure deck types that haven't topped in format library where I got the training data from, okay? Check out that video if you haven't. Okay, but here are the deck types that is in my data set that the model has tried to predict. So Badger Return, Cat, Chaos. I mean, the TLDR is that these deck types make sense. They're what my model trained on. There's nothing unusual in these deck classes. Next one, counting cards. So, 1 second. All right, yeah. So basically, what this thing is trying to show y'all is that I looked at the actual cards that my parsed data frame has, that my pipeline has parsed. All right. So what cards have my pipeline parsed from the replay data? And I looked at all of them. Well, not all of them, but like I looked at I counted them, and then I looked at the highest one, most recent one, all that. And what I've seen is that there was actually some Edison cards in our data set. Okay. So there were some Edison cards right here. Okay, right here. Okay. So we can see here that these cards for these game IDs, Allure of Darkness, that is not a go for my card. Okay. And I've done that through looking at the cards and just kind of manually verifying that it is what I expected. And when I look further, I found out that there's 2 matches from season 1 and season 6, week 4 and 5, where these players kind of thrown in an Edison replay. And I have the replay link here. But yeah, these were Edison replays, the only Edison replays in our data set. And we're going to have to filter these out, all right, to make sure that these cards and everything don't give us problems in our analysis. So I've filtered out those Edison games. So now we've done some cleaning. We kind of looked at the statistics of the numeric columns in our data set. And we've also verified that the classes and the cards are what we expect. So I have pretty good confidence that our model is pretty good. Likewise, throughout the different videos, we've kind of gradually, validated the data to make sure that it is what it is. It's not just something, scraped from Wikipedia or something, So it was already kind of clean, but now to be pretty confident that it's pretty good. Okay, cool. Next, we're going to create a data frame. This data frame is what we'll use for our analyses later. Okay, cool. So I'm not going to, again, I'm trying not to be too technical here, so I'm going to skip through some of this, but the end result that we want is this data frame. Okay. Yes. So the end result, so these are multiple steps here. The first step is this data frame. Matter of fact, I'm just gonna skip over it. Okay. We're gonna do some transformations. We're gonna, basically create some columns here. And the end result is going to be, all right, let's look at this one. So this is one step in this process. Look at this table, right? You have season 1, or you have the seasons column, you have the week column, game number, player, opponent, player 1, player 1 match. So these are columns that we're making. We're making a player 1 match column. So whether or not the player has won the actual match, the game score, whatever. So player 1 match, we got to calculate that. And it's going to be a Boolean, true player 1 match, or false player did not win match. Player as in this player column right here, not the opponent. Okay. Then we have a player 1 column. This is if the player won the game. Okay. So so this one right here, Nice Boy and Alice. Okay. You can see that for player 1, Nice Boy won game 1 and Nice Boy won game 2. Right, game 1 and game 2. And because they won game 1 and game 2, obviously they won the match 2-0. So we can see here that player 1 match has always been true. Okay, true. I agree. Alrighty, and then we're going to then finally create the cards data frame. Don't worry about how I did that, but basically how the data looks like at this point is this. You have your game, or rather, you have your player. You have all the columns that we've already discussed. Then I now have the player card name. So these are the cards that this player has seen in this game in matches, and along with the number of this card that was seen in that game. So you can see here that card amount is essentially the ratio of this card that Nice Boy have seen in this game. So he's seen 1 BLS, he's seen 1 Duo, he has seen 2 Spy, 2 Heavy Storm. Okay. So now we have this cards data frame, which basically has all the cards, all the columns that we need to do analysis across games, across matches, across seasons, between cards, between deck types, right? We have all of that now in this cards data frame. Feature engineering. What this means is to create some more columns. Okay, so we're not done yet. There are some columns that we have to make that is going to be important for analysis, but also for defining what our other deck type is going to be. So the first one is the deck partial feature. If you've seen the deck type model video, again, recommend it. If you've seen that video, you would know that I've been mentioning this word partial, deck partial. What that means is of a 40 card deck, assuming everything's 40 cards, of a 40 card deck, what percentage of cards were seen from a 40 card deck? So in this Nice Boy game, if he'd only seen 8 cards in that game 1, then for that game 1, he had a deck partial of 20%, assuming a 40 card deck. Okay, that's what deck partial means. It is the percentage of cards a person have seen from a deck per game. The reason why we're going to calculate this feature is because if you recall, actually, I'm going to mention it a bit more down because I know I covered it, but let's kind of start one by one here. So let's start with the deck partial feature. This is the percent of cards seen from a deck per game. So again, we're assuming 40 card decks. And this is a snippet of how that looks. So for player 1, this is how much cards you've seen in a game. Okay. I am Zine, have seen 13 cards in this game. And this is his player deck partial. So 15 divided by 40 gives him this partial. So this partial is going to be between, ideally, it's between 0 to 1. But if someone has seen 41 cards out of 40, it might be a bit higher. It's kind of irrelevant. So let's check out the distribution of our new feature. Okay, so this shows all the games in our dataset, how much cards are typically seen in each game. Okay, you can see here that there's a mean deck partial of 45%, almost 50%. On average, person per game has seen 45% of their cards. Okay, and you can see that the 25th percentile, it is 33%. The median is 43%. The 75th percentile is 55%. Okay, so this is the distribution right here. All right, where the highest is 100%. You actually don't see anything beyond this. So I guess all games were within 40 cards seen. Great. So this is our deck partial distribution. And I'm going to say this again. The reason why this is important is to define the thresholds to how we define what deck type is other. Okay, this is going to be important for that. And this will make a lot more sense if you've seen the deck type model video. All right. So we'll circle back to that later. All right, now we're going to make the side type feature. So this next feature is called side type. This defines whether a game is a pre-side or post-side game. And that, of course, means that pre-side is defined as whenever a game number equals 1, and post-side is whenever a game number is greater than 1. So, 2, 3, 4, 5, whatever, post-side. Okay? So this is how it looks like. So player 1, game number 1, and side type is pre-side. All these are pre-side because it's game 1. All right? Cool. So let's join these 2 new features that we made into one data frame. So I just kind of add in all the columns to our main data frame, which we'll use for analysis a bit later. Okay, so we can see a snippet of that. You see game ID, player card seen, their deck partial, game number, side type. Cool. All right, so now the reason why we did that partial calculation, we're going to now define our other deck type. Okay. So currently, our deck type model is trying to predict deck types based on the deck types it was trained on. So if you've seen the deck type model video, you would know that it was trained on a specific amount of card type, of deck types, right, from format library. It was trained on less than 30. Okay, and that means that if it tries to make a prediction on a deck, it can only really predict on the deck type that it was trained on. It wouldn't tell you a deck type that it wasn't trained on. Okay, so there's many possible deck types that wasn't in that training data that we might see in the World League. For example, Empty Jar wasn't in there, and Heavy Slump wasn't in there. Okay. There's also decks that just doesn't fit into any of these deck types and should just be lumped together in an other class. So we'll define how to label other using these features, the player deck partial and our model's confidence on its deck type prediction. Okay, so with these two features, we're going to try to define our other deck type. So first of all, deck partial. So recall in the deck model notebook, we know how our model performed on out-of-sample decks at different partial levels of 20%, 40, 60, 80, and 100%. We'll use those to build expectation given our data's partial distribution. So this is the performance curve of our model at different deck partial levels. So whenever my model sees a deck that only has 20% of the cards in that deck, it tends to be accurate 80% of the time. 80% of the time. On 40%, it's 90. At 60%, it's 95. And then it plateaus at 96. If you want to refresh on the reason why, you gotta check out the deck type model video. Okay, if you want to learn more about this, check out that video. All right. So we've already started looking at our data's partial distribution here. But let's see if the distribution changes by game number. Because this is going to be important, right? This is important because we'll be labeling deck types by the game 1 prediction. So essentially what I'm saying here is, once you start doing match analysis, like analysis on a full match, whether this person won a match and what happened, all that, the deck type that we will be using for to define what that match deck type was, like what Nice Boy used in one match, we're going to be using the prediction based on game 1, right? And we're going to do that based on game 1 because, post side, there might be a smoke screen. Post side, if I'm on, a Chaos Turbo main deck, and, let's say I have a post side strategy of 3 Blade Knights and 2 Rotas and Sakuretsus and all that. Say I have that post side against Warriors and I bring that in post side. Now my deck type might be predicted as Chaos Warrior Turbo, right? Because now I have this Warrior package, but I also have Thunder Dragon and all this other shit, right? So we're going to be basing match deck type predictions on the game 1 prediction. And so we know what our partial distribution looks like across all game numbers, right here. But we want to know how the partial distribution looks like for game 1, right? So here are the deck partial distributions by game number. So we have, so game 1, so it's pretty consistent, right? They're all pretty consistent. Game 1, game 2, game 3. Game 4 is a bit higher. I kind of mentioned it here. So the distributions are pretty consistent. Game 4 seems to have a greater mean, but that makes sense because the kind of decks that tend to draw may be more stallish, right? So that said, let's narrow down the statistics for the deck partial at game 1. So let's actually look at the statistics for game 1 decks partial. And let's look at this, right? So here are the game numbers from 1 to 5. Here's the number, the sample of those game numbers from 1 to 5. And here's the mean deck partials. So for game number 1, there's a mean deck partial level of 45%. And then we have the median here at percentile 50 is at 42%. And percentile 75 is 55%. Right? But all the way down to percentile number 1 is actually 17 or near 18%. What this means is that at this first percentile of this data, like 70 games of this data, the lowest is going is like 18%. All right, 18% deck partial level. And what that means is that is not too far away from the 20% partial level that we looked at for its performance curve. So even at the very lowest level, at 1% of games in our data set, we could be pretty confident that at the very least, my deck will be 80% accurate. Okay. But since the mean and the median is in the 40 level, most of the times it's going to be between 40 and it's going to be between 90 and 95% accuracy. Okay. So that's the expectation here on if we're basing the model on this on these features. The reason this is important, the reason why we're going through this is if our deck type modeling is not going to be very accurate in some cases, we're going to try to set a threshold for what we could define as utter. Because if something, because if the model confidence, we'll talk about confidence in the next section, but if our model's confidence is not very high, I'm just going to set a threshold for what we will define as utter. And what we expect to find for utter would be deck classes that wasn't in our deck type modeling. So I actually have an interactive section down here where we actually look at the lowest confidence levels, and we kind of go up from there, and we kind of see what kind of decks, what kind of cards are in these decks. And what we actually tend to see down there is like heavy slump. We see decks with Centurion that like don't make sense. It wouldn't actually be a deck type. We see like empty jar, right? Like we see deck types that either wasn't trained on because of low sample, or we see decks that actually would classify as utter. Either way, these are deck types of low sample. Okay, so we're actually going to try to define what a good threshold would be to label deck types as utter. Cool. So the median is at 42%. Based on our model's performance curve, a 40% deck partial will give us a model accuracy of about 90%. But there's some caveats. That performance curve was based on the model predicting out-of-sample decks within the deck classes that the model is aware of. There's going to be deck types in our Word League data that the model would have no idea about. This should make the accuracy a bit lower, but at least we know what to expect. So what this is saying is that the performance curve that I just showed you with the different partial levels and how the model performed, that was when the test set that it was given had the same classes that it was trained on. So there's no new classes that was thrown at it that it had no idea about. You know what I'm saying? So we can expect the accuracy to be a bit different just because there would be unexpected deck types here that the model would just not know about. Again, things that we want to classify as utter. Because these deck types, again, would be ones of either low sample or just does not belong in the category that we care about. Okay. Deck type confidence. So continuing off of defining what an utter threshold would be, so let's follow this up with analysis on the model's prediction confidence. In the deck model demo notebook, we looked at examples sorted by confidence. Okay, this part was on the second part of that deck type model video. Again, check it out if you haven't. We looked at 10 examples where my model predicted something different from what format library, our training data was off of format library's decks. Okay, so we looked at 10 examples out of 20 where my model predicted differently from format library, and we saw that 9 out of 10 times, pretty much every time except for one time, there was a mislabeling with our training data. Okay, so but in this deck model demo notebook, we looked at examples sorted by confidence. So we also looked at those examples and looked at how confident our model was in those predictions. Because ideally, what we would like to see is that when the model has low confidence, that would be they would be confronted with a deck type that they was not trained on. That is a prime area to start labeling deck types as utter when the model has low confidence. Okay. So it's small sample, as in like the demonstration that we did, 10 examples. It's small sample, but typically when the model is confident, it tends to be accurate to the point that it tends to correct mislabelings from our training data. So again, check out part 2 of that deck type model video if you want to know what I'm talking about here. But basically the moral story is this deck type confidence value that we have from 0 to 100%. If the model is confident, we could be assured that it's probably predicting something that it was trained on, something that it knows about. And on the flip side, if it's low, then it might be a deck class that it does not know about, which we want to label as utter. Okay. So, however, confidence thresholds for an utter class is going to vary. Let's first look at the confidence distribution. Okay. So across game numbers, this is the distribution of the model's deck type confidence. Okay. Well, what we can see here is that there's a strong left skew here, where the majority is like between the majority is in the 90s. Okay, but there's some tails, right? There's some tails all the way down to like 25%, probably even more, right? And I'm looking at game 1 because this is going to be important once we start defining what deck type is for a match. Okay. Okay, cool. And unsurprisingly, the distribution gets a bit wider once we go into game 2 and game 3, because again, like I said, you start introducing some side cards, it would mess up how the game 1 deck type would actually look like and be defined as. Okay. All right. Okay. So the deck type confidence has a strong left skew distribution. Let's look at the numbers. Okay. So these are the game numbers from 1 to 5. And this is the same distribution statistics that we were looking at, or these are the same descriptive statistics that we were looking at with deck partial. But now we're doing it for confidence. And what we can see is that the median is 99%. So most of the time, the model is very confident. But if you go down to percentile 5, it drops down to 60, and percentile 1 is 34. To put this in perspective, the deck partial at P1 was like 18%. And we know from the performance curve, the 80% partial will give my model accuracy maybe an expected value of 80%. But so we can see here that for P1, confidence is actually 34. So we see values that is obviously ranging here from, let's say, somewhere in the 20s to 1, or somewhere from the 20% to 100%. And we want to know at which threshold would it be appropriate to define deck types as utter. Okay. So the first thing I want to do actually is that I have my partial feature and we have our confidence feature. With the partial feature, I actually have I have some kind of analysis to know at what partial levels my model tends to perform at. So, again, 20%, 80. But I don't have the same thing for confidence. So I actually want to see the relationship between the partial level and confidence, because I want to use confidence to define the other category, because that is the best signal to know whether it is being confronted with a deck class that hasn't been trained on. Okay. So partial and confidence regression. So if you look at this here, in this y-axis, we have the deck partial level, right, from 0 to 100. And then on the x-axis, we have the deck type confidence from 0 to 100. And what we can see is that there is a positive regression, or a positive slope here, okay? But what we can also see is that in the tails of this deck type confidence, there's big residuals. And what that means is it gets very noisy as to whether something has 100% confidence, which honestly kind of makes sense, right? Because at 25% confidence level, the model could be very confident that those 8 or 9 cards is equal to a Chaos Turbo deck, right? It could be very confident in knowing that. So it makes sense, but there's a positive relationship here. So that's kind of how the regression looks like. So there's a positive relationship, but big residuals at the higher confidence levels. You can't just use this regression model to predict deck partial, Let me kind of skip over. Okay, so here's the moral story here. So we kind of have an idea of the confidence and partials of our deck, and we're trying to kind of put that into perspective with our performance curve from the deck type model video. And the whole point of this is that we're trying to use the confidence level to determine what we should define as utter. Okay, so we're going to look at the data case by case, deck by deck, game by game. We're going to go from low confidence to high confidence to see what to expect and what a good utter threshold would be. So this was an interactive section here. We're actually not going to go over this here because I feel like I'm kind of dragging this section. For those who are trying to, keep it together, this stuff, all this shit that I'm kind of saying, the actual questions, the actual good stuff that y'all want to know is like right after this, all right? So like this is just this is the hard part, okay? But it's important because I'm trying to be very transparent about my model, about what I'm defining as utter, all that shit, all right? And I'm also trying to instill some confidence as well, because I'm actually very confident in everything that's going on here. Okay, so there's actually an interactive section that I did before. So I've actually went through each game, and I went from confidence level of as low as like 18% all the way up to like 60, okay? And when I did that, I noticed that at the low confidence level, indeed, the majority of that was deck classes that the model was not trained on. So it was like, I was seeing heavy slump decks, empty jar, all that. And it wasn't until I reached about the 50% threshold that things started to look like deck classes that the model should have been trained on. Okay. So I'm setting the threshold level of 50%, basically. So given what we've looked at so far between deck partial and deck confidence, I'm going to define utter as deck types with a confidence lower than 50%. So now I'm going to add this utter deck type for whenever the confidence meets that condition. Okay. So whenever confidence is lower than 50%, call it utter. So for Alisai, this deck right here, calling it utter because it's less than 50% confidence. All right, great. All right, so now we're getting to the analysis. Okay, so that was the hard part, guys. So just kind of don't worry about that no more. We defined what utter is. Now we're going to actually get to what the data is saying about cards, matches, matchups, all that. All right. So first things first, we're going to do a count here. Okay. So we're going to do a matching game count. So just to kind of know how much samples we have in the data. So across the seasons, this is our match count. So season 1 had 560 matches, season 2 820. So we can kind of see that the majority of matches was in season 2. That was our biggest season, and so it went from about 560, 820. Season 3, 4, and 5 had pretty much the same amount of matches, so looked pretty good. And now season 6 kind of tapered off a bit, tapered off hard actually. So it was at 540. Okay. Then we had the game 1 count. So for game 1s, how much count was there for that? As there. And then game 2 count, game 3, game 4, and then game 5. Okay. And then we have the total game counts. Total game counts from game 1 to 5 per season. Okay. In the thousands. Now we have some perspective on the samples of our data. All right. Now we're also going to look at the class. Okay. We're going to be looking at the class count in our data. So the majority of classes in our data set is obviously Chaos Turbo, match count. So over 1,500 matches were with Chaos Turbo. Second most would be Warriors, Go Control, Chaos Control, Panda Burn, Earth Beat, Utter, etc., etc. Okay, cool. Now we're going to see the match count across the seasons. All right, cool. So these are actually the deck types across the seasons. So we can actually see popularity, and these deck types are normalized by the season. So you can see the y-axis is by percentage. So for instance, Chaos Turbo would be right here. So for Chaos Turbo, we can see that as of season 6, Chaos Turbo was over 50% of the matches in season 6. Right, it's normalized by the seasons. Okay, so Bazoo Return, you can see that it's been declining. Cat with Decay kind of went up, and now it's kind of declining again. Chaos Control been declining until season 6. It is a little bit more. All right. Chaos Turbo has been steadily increasing in popularity. Kind of plateaued at season 6. Chaos Warrior down. Chaos Warrior Turbo up. Shout out Pikatron. Drain Burn down there. Economics down there. Tomato Monarchs in hell. You know, so on and so forth. Warriors have been weirdly going down as well. Okay. All right, cool. Panda Burn down, obviously. All right, great. So, this notebook is available for y'all in the repository that I've shared. I'm also linking it in the description so that y'all could actually see these charts yourselves if you want to spend more time with it and look at it and all that, okay? So if y'all want to see this shit later, check out the description. Let's go down here. All right, win rate calculations. So before hopping into win rate, EDA or exploratory data analysis, there is a problem with sample size. So let's walk over our options for dealing with this. So the straightforward one, the best one, honestly, is to remove low samples. So this is the most straightforward one, but defining the sample threshold is tricky. So at what threshold to sample things out? If there's big differences in the relative size, okay, so it's tricky because if there's big difference in relative sizes. So for example, let's say we have a safe filter out for samples less than 10 or 50 or whatever. Say you just want to sample out everything that's less than 10 or 50. However, if I'm comparing calculations from a sample that had 500 and another that has, 20, the 20's variance is going to stick out so hard, right? The 20 is going to be either as the tails high or low, okay? And it's just going to skew what the top results are because of the sample. It's not at the same variance level as the 500 sample. And that just kind of makes it tricky if I want to see things in order, okay? So, but at the same time, if this other sample, although it's less than 500 by 10 by magnitudes, there's still enough data here that there's some kind of signal in it, right? 50 is a pretty decent sample, all right? All right. So, but yet the 50 sample, there's enough information there that I don't actually just want to filter that out just because it's not the same as like the samples that we'll see with Chaos Turbo, okay? Especially because we'll end up losing so much deck types, analyses. All right, Laplace smoothing, don't worry about it. We're not using it basically, okay? Wilson score interval. I actually like this one a lot, but it doesn't actually give you an adjusted win rate. Okay, so this doesn't calculate an adjusted win rate. It gives you 95% confidence bounds of the true win rate. So for example, a deck type has a win rate of 50%, but with low sample. There could be wide bounds between 25 and 75%. Okay, so say I have a deck with a win rate of 50%, but it has like 2 samples. The confidence bounds for this might be really wide. Like again, like it could be between 25 and 75%, might be within the true win rate. Okay. Whereas something with a higher sample could be between 95 and 51 because it's a lot more confident to know that the variance is a lot tighter. It knows that the win rate is actually is actually within 49 and 51. So what people would actually do when it comes to Wilson score interval and win rate calculations is that they would actually pick the lower bound. I think it's called like a Wilson score lower bound. They would select the lower bound as a conservative estimate of what the win rate could be, right? And I think I'll mention it a bit here. Okay, so aside from adding some perspective on variance, the conservative use case is to use the lower bound as a safe estimate for the win rate. But there's a few problems. If the win rate is lower than 50%, the lower bound would go lower than that. It wouldn't actually, because what I would expect is that if something has low sample, right, and say it is at 49%, I wouldn't expect the win rate just if I use the lower bound, something with low sample has like 45%, the lower bound could go lower than that, right? It could go to the 30s, right? And what I would actually expect is that the win rate to actually go more towards 50%, right? Okay, so if the win rate is lower than 50%, the lower bound would go lower than that, while we might expect uncertainty to go more towards 50%. You can gauge the relative variance of low sample calculation by just looking at sample size. Okay, so the actual value of seeing whether or not something has more variance than another thing, you could tell just by looking at the relative samples, right? So if something has 50% or 50 samples and another has 5,000 samples, you could just look at that, look at that number and know that it has high variance. I don't have to know the actual 95% confidence bound number. Okay, so as an estimate, it does not have the behavior that I would expect for something that is uncertain, because I would expect it to go more towards 50%. And on the other side as well, the other value to gauge variance is not very important either. So that's Wilson score interval. It's decent, but not very useful. The one that's actually pretty useful here is the Bayes estimation. You could combine. I'm not going to go into detail with Bayes estimation here, but you could combine a prior belief about the win rate with the likelihood of observing the data to compute a posterior distribution. The posterior distribution reflects your updated belief about the win rate after accounting for observed data. Okay, so what that means is, say I'm doing this analysis, I'm going for my World League data, but I have low sample. What I would actually do is look at other similar data. Like say I have Warrior data, but for like in another kind of space. Okay, I would actually use the analysis from that observed data, and I would have a prior, which would be like what I would expect. Let me put it like this. I'm trying to do analysis on Go for my World League data. All right, I have low sample though. There is another pool of data where there's analysis on like tournament stuff. And in that, I could see that Warrior versus Chaos Turbo at high sample might have let me change that. I could see that Chaos Turbo versus Go Control has a win rate, a high sample of 60%. I could use that as a prior coming into my low sample World League, analysis, and say that instead of things going down to 50% or up to 50% when there's uncertainty, I could actually go for this prior of 60% for the matchup of Chaos Turbo and Go Control, and then that would be adjusted as more and more samples added in the World League. Okay, cool. So like it's basically using past data, basically like you're using past data somewhere or some like similar data to give you a belief that you could set expectations for how you would weigh your win rate and at what level. Okay. So here's what we use. All right. So this is a simplistic method that incorporates elements of Bayes estimation. Basically, we have a prior belief that the win rate should be around 50%. That's like the default, beta 1-to-1 kind of belief that whenever there's uncertainty, it goes towards 50%. And K is how strong we'll weigh that 50% based on what sample size we think the calculations are more accurate. So if there's low samples, we're going to be weighing the win rate towards 50%. And K will be how strong we'll apply that weight. And we can know what K should be based on what level we think, at what sample we think that we could get a lot more signal from the data. So, it depends on the samples. It depends on, your domain knowledge of the calculations, but we could look at everything in a moment. Okay. So this is the adjusted win rate formula that I'll be using to calculate win rate. And the TLDR of it is, if something is in low sample, I'm going to be weighing that win rate towards 50%. Okay. And if something is of high sample, then this adjustment is not going to, the adjustment is not, you're not going to feel the adjustment. Okay. A higher sample is going to be normal. Okay. All right, cool. So here's the function. We're going to set a default K weight of 50. All right, cool. And just to show you how that impacts the win rate, I have a demonstration here. Okay. I have a demonstration with a sample size of 500. Actually, give me a second. Yeah. So I have a demonstration of up to 500 samples, and I have the fixed win rate at 60%, and I have a K as 25. So let's look at this chart. What this chart shows is that from 0 to 500 sample size, the adjusted win rate goes from 50% at the low samples, and it goes up and up and up until it starts reaching this red dotted line where the fixed win rate is actually 60%. So we can see that after a few hundred sample size, the adjustment starts to waver off strongly, okay? Where it actually starts to go more towards the 60. That's what the adjustment is doing, all right? This is how it looks like. It's the curve, okay? All right, cool. So that's very important to kind of cover. That's probably a bit technical as well, but it's very important because all the win rate calculations will be done with that, okay? All right, deck type match win rate. All right, non-mirror. So here we're actually getting into the charts. All right, now here we're going to get into the actual analysis of the actual findings from the World League data. Okay. All right, first of all, so best and worst deck match win rate. So these are the non-mirror. So for non-mirror, this is how these decks perform across all the seasons, across all the decks. What are the best decks, right? With the best non-mirror win rate. So we can see here that the number one deck is Chaos Turbo at 54.8%, and it's colored by the sample. So Chaos Turbo is up here over 1,500 samples. Of those 1,500 samples across all the seasons, it had an adjusted win rate of, it adjusted or unadjusted, the sample's a lot higher than the K value, obviously. So it basically has a true win rate of about 55%. Then below is Cat OTK, and this is where the sample kind of tapers off. And this is why you kind of see how the variance changes as sample kind of changes as well. So you can see the very bright colors here with Chaos Urban Warriors. They have the most samples, whereas the lower samples here in the purple would be like Cat OTK, all these other things in here. Okay, it's still being adjusted, their win rate, but I just wanted to put that disclaimer that these samples are changing now. Okay, so we got Cat OTK here at 54%, Tomato Monarch 52%, Mataza 52%. So on, Chaos Warrior Turbo 51. We're getting to the 50s. Okay, Warrior 51, Flip Warrior 50. Then the worst decks. The number one worst deck is this other category. Okay, this is decks that again is either not of the deck classes that the deck model knows of, which means basically low sample decks that doesn't top much tournaments. Those kind of decks. So this is like the empty jar. This is the heavy slump kind of decks. The obscure, mishmash type of decks. The next lowest win rate here is Reasoning Gate Turbo. Next one is Go Control, Zombie, Panda Burn, Flip Control, Economics, Earth Beat, Bazoo, Tiger Stun. Okay, these are the worst decks. Cool. All right. So now we're gonna look at the most lopsided matchups. Okay. Okay, cool. This is actually a demonstration as well. So all this code here. So all of this code basically produced this table. This is a sample of this table. What we can see here is that this is the player's match deck type. So we got Bazoo Return, and the opponent's deck type was Cat OTK. Okay, so we got Bazoo Return versus Cat OTK. And for this matchup, Bazoo won once out of a sample of 1. Okay, so there's actually only one sample in this matchup of Bazoo Return and Cat OTK, and Bazoo Return have won once. Okay, and what we can see here is that if we calculate the win rate purely, this would have a 100% win rate. Okay, 100%. But because we adjusted it, it's actually about 51%. Okay, that's the point. And there's tons of these examples where the count is really low, right? Even this one. Bazoo Return versus Chaos Turbo, right? 4 out of 9. It says 44%, right? Is the true win rate actually 44%, right? If actually it could be. Oh shit, but whether or not Bazoo Return wins or loses the next match, this win rate, changes by by like 5 or 6 digits. You know what I'm saying? So like it's just very unstable at low samples, and that's the point of the adjusted win rate. So that's just kind of a demonstration of it as well with actual data, and this also shows how they would look like once you start looking at the matchups analysis. Okay, right. So now here are the most lopsided matchups. All right. So I got each matchup, and I got the win rate for each matchup, the adjusted win rate for each matchup, and I've ordered them by which one is most lopsided. So you can see here Chaos Turbo versus Go Control. This has the greatest adjusted match win rate value. So Chaos Turbo has a 63% adjusted match win rate of Go Control with the highest sample as well, right? So this is like almost true. Chaos Turbo has a dominant Go Control matchup and it's the most lopsided. If you want to know what the opposite side of this, it would be Go Control versus Chaos Turbo. So that's why there's not a top and bottom lopsided matchups. It's the same thing but reverse, right? So number one, the Chaos Turbo was Chaos Turbo versus Go Control, and the lowest one would be Go Control versus Chaos Turbo, right? For 37%. Okay. The next most dominant or most lopsided matchup is Chaos Turbo versus Utter. Next one is Warrior versus Reason Gate Turbo. Next one is Chaos Turbo versus Panda Bird. I saw some people discussing in the Go Hub about Panda Bird matchup. It's top 4, all right? It's very good, all right? All right, Chaos Turbo versus Zombie is also very good. Warriors versus Chaos Return is pretty good. Chaos Turbo versus Chaos Control is pretty good, right? So on and so forth. And again, if y'all want to spend more time looking at the charts, the repository is available and in the description. All right, matchup matrix. So this is a pretty similar matrix to what you would usually see in the Excel sheets or with the with the league bot. It's the same thing, pretty much. So this is the matchup matrix. You're gonna have to zoom in. Oh man, you're gonna have to zoom in. Looks like I don't have the option here. Let me get out of Zen mode. Let's see if I could. That's tough, gang. All right, well, whatever. All right, let's go back here. Let's actually zoom in. All right. All right, you know what? It looks chalked, I ain't gonna lie, but let me look at let me look at the notebook actually. So we're gonna go to oh man, github.com, format sticks, script. Oh, all right, notebooks. Go for my Word League analysis, matchup matrix. Here we go. All right, so here's the matrix. So it's very similar to what you usually see in the Word League. You can see here at the first tile here is non-mirror. Okay, so this is a non-mirror win rate. Okay, so I've added that in there along with the rest of the matchups. Okay, so we can look here let's look for strong colors. Okay, so strong colors, we see that we have this color right here. A really strong green color here. This is between Chaos Turbo and Go Control. So we saw that this was also the best matchup as well, right? So you can see here that is 63%, as it said. And you can also see the sample as well. So if you want to calculate the true or the actual win rate without the adjustment, you could do that manually if you want. But Chaos Turbo beats Go Control by this much with that sample. Okay. And you can also see that Chaos Turbo has a non-mirror win rate of 55% with that much samples. Okay. We've seen that with the non-mirror top and bottom 10. Okay. Let's look at some other stuff here. So Go Control 37%. This is with the Chaos Turbo, so we know that. All right, next one, Utter. Utter is losing hard in general, 40%. Not much, about 200 samples. And it loses pretty bad to Chaos Turbo, of course, 40%. Cool. All right. Let's look at some other colors here. Reason Gate Turbo is 44% non-mirror, but it actually has a 53% here against Chaos Turbo. We'll look at that a bit more later. But Reason Gate Turbo has a 53% win rate against Chaos Turbo with a sample of 71. All right. And check this out, right? Like, look at this. So this would be Reason Gate Turbo against Go Control. So this would be Reason Gate Turbo against Go Control, and it's 3 out of 10, 0 to 5, right? These would be such bright colors. It will stand out. It would be noisy. You know, it wouldn't be very useful. You know, so that's why I just did win rate. Okay. And check this one out, right? 520. So this is actually a good sample. This is one of those examples where I wouldn't want to filter this out. But if I would have kept the true win rate there, yeah, so this is one that I didn't want to filter out. But Let me see this. But if I wanted to do the true win rate or the actual win rate calculation there, it would say 25%. And it would look crazy, right? So this matchup is Recent Gate Turbo versus Warriors. Recent Gate has a terrible matchup versus Warriors. All right. 5 out of 20. Let's look at some more stuff here. So Panda Burn, we saw that. Chaos Turbo has a 56% win rate against Panda Burn with a sample of 144. Okay. All right. I think we could kind of move on from this. Yeah, so this is the matchup matrix. If you want to take a look at this, zoom in, scroll around, all that. You can see all the matchups and non-mirror. Okay, great. All right, cool. Okay, so let's kind of move it on here. So that's the matchup matrix with adjusted win rates. So most improved matchups across the seasons. Okay. Alrighty, so we have here from seasons 1 to 6. All right, let me break this down. So I have the win rate of season 1. Well, I have the win rate for each seasons. Okay, for each matchup. For each season, for each matchup, I have the win rates. And what the axis is the difference between season 6 win rate and season 1 win rate. So what that means is for Chaos Turbo vs. Gold Control, it has improved by 6 points from season 1 to season 6. Okay, that doesn't mean that the growth of that was linear. It doesn't imply that it could be going up and down, but the difference between season 1 or season 6 and 1 is 6-point difference, right? And also in parentheses here have the season 6 win rate. So the season 6 win rate is 59%, right? It's improved from season 1 to 6, 6%. And it's really important as well that I add this parentheses with the actual win rate, because we can see here that Other versus Chaos Turbo has been improving. So what that means is that we know that Chaos Turbo versus Other has a really dominant win rate. But Other has been doing a bit better from season 1, right? It's improved 5 points. But the win rate is still 47%. So it's still really low. All right. Then Chaos Turbo versus Panda Burn. Chaos Turbo has been dominant, improvingly getting better against Panda Burn from season 1 to 6. You got 5% there. Let me actually look at something real quick. Okay. All right, yeah. And then so on and so forth. Chaos Turbo actually improved by 0.5%, but we'll see in the Chaos Turbo vs. Warriors analysis section a bit later in more detail what this means. Because at the end of the day, there's a lot of gap, between season 1 and 6, and things go up and down, things change. And so in this next chart, I actually looked at the most improved matchups from season 5 to 6. All right. So this is the same calculation, but I'm doing it from season 5 to 6. So this is the difference in the matchup win rate from season 6 from 5. Okay. So if you look at this, Warriors versus Chaos Turbo has improved the most by magnitudes. Not magnitudes, but like by a lot. You know what I'm saying? So we can see here that Warriors vs. Chaos Turbo had a 15-point improvement from season 5 to 6, with a season 6 win rate of about 57%. Adjusted, everything adjusted, obviously. Then you got Chaos Turbo, and this has high sample too. This is the highest sample that we have. Then you got Chaos Turbo versus Go Control. It has been improving from season 5 to 6. Canterbury has been improving against Chaos Turbo from 5 to 6. So this kind of tells you the most recent trends, right? So most recently, 5 to 6, Panda Burn has been improving. Earthbeat has been improving. Relinquished has been improving. Recent Gate Turbo has been improving. Otter has been improving. Chaos Turbo, a lot of decks are starting to kind of figure out Chaos Turbo. Is basically what I took away from this chart. Okay, a lot of decks have been improving from 6 to 5 against Chaos Turbo. All right, let's kind of take away. With moreover, Warriors versus Chaos Turbo being very, very crazy here. All right, cool. So now we're going to look at deck type game win rate. So the best matchups when going first. All right, cool. All right, so the first thing I showed here is actually the distribution. This is something that I kind of wish I covered more, the going first stuff. I actually did not cover here in this notebook what your win rate would be like going first in aggregate. Wish I did that. I think I did before, but I didn't include in the notebook, but it was definitely very high. I think it was very close to the calculations that we've seen before in one of the Excel sheets in the World League, somewhere like 60 to 65%, something like that. It was something like that. All right, cool. So the first thing I posted here was actually the distribution. So what we have here is, a second. Okay, so what we have here, so we have all these matchups and all of their win rates. So we have all matchups with their win rates when they win first and second. So all of these matchups, if you win first, you're in this red density distribution here. And what you can see here is that your adjusted game win rate when you go first for these matchups has like this point here at between 55 and 60%. And then for going second, you can see that's different. You can see that it kind of shifts down here to like between 40 and 50%. And obviously there's some other lumps in here as well, and that's usually because there's some deck types, there's some matchups where it doesn't matter if you go first or second, you're just going to lose because the matchup is that bad. So that's why you have these second lump in here. Okay. But yeah, that's the distribution. That kind of just shows how distinct it is, whether you go first or second, how that affects matchups win rates. Okay. So now this is going to be okay. So let's prepare for our next feature. So what we're going to do now is okay, cool. Let's actually get here first. All right. So a second. Let me check if I did something first. It looks like not. Great. Okay. So in this chart right here, on the y-axis, this shows the game win rate difference between going first and second. So I have the matchup win rates, and I have it going first and second, recall. So now that I have that, what I did was I subtracted them. So I got going first win rate minus going second win rate. And what you would expect to see when the win rate, what you expect to see is that if a person goes first, they would have a better win rate than going second. So you would expect a positive number from this difference, right? So the y-axis is when you go first for that game, what's the difference between that and going second for a game? This does not control for what game number. Okay, so this could be game 1, game 2, pre-side, post-side, so just keep that in mind. All right, this is the difference. You see here, okay, so that's the y-axis. What the x-axis is that we have the going first win rate and the going second win rate. What I did was I took the mean of those samples, like how much samples was going first and going second, and I averaged them. And I averaged them here in the x-axis. And the reason why I did that is because whenever a higher sample, what you see is that every matchup, when they go first, they have a much better going first win rate than going second. Right? Pretty much after you pass this 20 mean game counts sample size, everything is positive, right? Everything is positive. And it goes all the way up here until you hit this sample right here. Okay. So, the moral of the story here is that there's a really positive slope. And then once you go past a certain sample size, pretty much unanimously, if you go first, you're going to do a lot more better than going second for all matchups. Which is like a no-brainer, but like this is kind of plot, the chart showing that. Okay. And also showing how the sample size is going to affect that as well. All right. Okay. With that out the way, let's finally look at the matchups whose win rate is very impacted by going first for a second. So what I want to see is, actually, let me check something first. Okay. Okay, yeah. Okay, so what I want to see here is that, you usually hear talk about like, maybe Warriors, they got to go first when going against, a certain matchup because they got to set their cards. And it's very impactful. Whenever they go second, they're at a big disadvantage, right? So basically, what I wanted to show here is that which ones benefit the most from going first, right? Which one, or which one is indifferent. It doesn't really matter if they go first or second. Okay, so that's kind of what this plot is going to show. So matchups that are way better going first and second. So the x-axis here is the game win rate difference between going first and second. This is the same value that I just described in the y-axis of that regression. So this is the going first win rate minus going second win rate. And we can see here at number 1, Steingate Turbo, whenever it goes first against Chaos Turbo, it has the greatest difference in going first and second across games. And again, this is across games. So this is game 1, game 2, this is post-side, all of that. If Steingate Turbo goes first against Chaos Turbo, it has the most, it benefits the most from going first. And next we have Warrior versus Panda Burn. This makes sense to me because Warrior has all them, cards, all those traps you want to put down, maybe prevent trio, this is just showing that, okay? Next one is Chaos Turbo versus Chaos Control. It just steamrolls over Control once it has that first summon. So I can see Chaos Turbo being in a lot of these top ones up here. Then you got Warrior versus Chaos Turbo. Big one, right? Because couldn't control, or I didn't control for game number here, but let's say game one, Warriors went first, right? If Warriors went first, Chaos Turbo, I can't use Dust Shoot, right? So it's cases like that where they go first and they just have all the stuff. They have their Dust Tornado set, right? And they could just pop traps, attack over flips, so they're number 4 here for matchups that are way better going first and second. You got Chaos Warrior versus Warriors, Chaos Turbo versus others, etc. All right, Region 8 Turbo versus Warriors make a lot of sense. Okay, cool. You can see Warriors over here, like being on going first versus Warriors matters a lot, right? You can see here 1, 2, 3, 4. Warriors is the number one thing here, actually. Warriors, yeah, when it comes to going first against them, which kind of makes sense given their trap lineup and their pressure and stuff like that. Cool. Okay, now we're going to look at the best matchups pre-side versus post-side. Okay, so pre-side is defined as game number equals 1. Post-side is defined as game number greater than 1. So 2, 3, 4, etc. Okay, cool. So this is actually what we expect to see here. Okay, so this calculation is the same one with the going first and second, except we're now doing it for pre-side versus post-side. So just kind of rehash that. X-axis, this is the game win rate difference between pre-side and post-side. So it's the pre-side win rate minus the post-side win rate between all these matchups. And what we see at number 1 is that Warriors versus Chaos Turbo, game 1, pre-side, it is 11 points better than their post-side. Okay, it makes a lot of sense, right? And then number 2, actually, all these is what you would expect, right? Because what you see is that the matchups that benefit the most, pre-side and post-side, are stuff that gets slammed post-side. We're talking about Panda Burn, Warriors in some seasons. So we got Warriors in some seasons, Relinquish, Cast Return, Panda Burn, and Panda Burn. Okay, so matchups that are way better pre-side and post-side. And I guess the moral of the story of this is, actually, don't worry about it. That is this chart. Great. Okay, so now we went over the matchups. We went over deck types or deck class win rates. Now we're going to talk about the card win rates. Okay, card game win rates. All right, here we go. So best and worst cards. Okay, so the best cards right here, we got Pot of Greed, Charity. This is the adjusted win rate, colored by the count. Okay, and this is the game win rates, obviously, because if someone seen Pot of Greed game 1 and they've won that game, I don't care about game 3 if they don't see Pot of Greed, right? It's game 1. So this is game win rates for cards. So for Pot of Greed is number 1. You see Pot of Greed, you have this adjusted game win rate of 61%. Graceful Charity, number 2 is 60. Card Destruction, 57. BLS, 55. Duo, Radiant, Phoenix, Sangan, Breaker, Thunder Dragon. And then you have the worst cards. The bottom one down here is Goblin Attack Force, Lightning Vortex, Lady Assailant, etc., etc. So one thing to keep in mind here about best cards and worst cards is that depending on how specific these cards are to a deck type is going to influence its placings on here. For instance, you might look at a Mindless Radiant here and think that how is this card better than Breaker or something? And the reason is that it's up here is that Mindless Radiant is only played in Cat OTK decks. It's not played in all these other garbage decks. Okay, so Mindless Radiant is only played in Cat OTK decks, and we've just seen a few charts ago that Cat OTK had the second best non-mirror matchup win rate. Okay, so that's why it's up here. You can say the same thing for Card Destruction. Only Chaos Turbo plays his deck, and Chaos Turbo has like a 55% adjusted match win rate. Okay, same thing for some of the other cards, like Phoenix Wind Blast. Same reason. Okay, so cards that are very specific to a deck type that does well anyways, that does well in general, is going to be seen up here. It's not normalized for those kind of things. Okay, and likewise for the bottommost cards, right? You might see cards down here that you might see in other, Gigantes, Brain Control, Lightning Vortex, cards that just suck. All right, or is usually just seen in bad decks. Okay, cool. Likewise for Exile Force. That's why Exile Force is down here as well. A lot of garbage decks probably play Exile Force. Okay. All right, cool. Best and worst cards when going first. So obviously, I'm gonna have to clarify again that my data at the moment does not show like what cards someone has seen in the opening, right? It shows what cards someone has seen in one game. I also have who went first in that game, but I don't know what cards they've seen like in the opening hand, right? If you've looked at the replay parts of the video, I think last video, you can see where there's opportunities to add that. You could add that because the data is in the JSON. You could add that to the cards dictionary, and you could have that. So you could have that, but that's not what this is. So I just want to clarify that best and worst cards going first, it is not implied that these cards were in your opening hand. Okay? All right. So let's look at this. Cards that are way better going first than second. So best cards going first. So, you could kind of look at this as, there's a lot of, how do I say, there's a lot of overlap here with this chart because we know that Chaos Turbo has a pretty good win rate against most decks when it goes first, right? So seeing a lot of Chaos Turbo cards here is kind of why you're seeing this, right? So you have Thunder Dragon, Spy, you do see Trap Dust Shoot up here, all right? But you got to kind of try to balance that out with the fact that a matchup that contains these cards benefit a lot from going first in general anyways. So you have Thunder Dragon, Spy, Dust Shoot, Night Assailant, Dekoichi, Nobleman, Kaiku, Fate, Jar, Sorcerer. So like some cards that like will kind of make sense here would be like Dust Shoot, Night Assailant, Jar Greed. Flips is obviously better going first, I think. Especially non-spy flips, but Spy's number 2, so cool. All right, so best cards going first and best cards going second. So these cards, let me actually just back up a bit here. In this x-axis, this is the adjusted game win rate difference between going first and second between the cards. Okay, so for each card, the win rate going first minus going second. So if you see a surplus, that means that card performs better going first. If you see a negative value, then that card performs better going second. Now there's no card. So this bottom 10, you can see that it doesn't even go below 0. So like cards going first and second, going first is just way better than going second in general. But you can see all the way down here, the card that least matters, whether you go first or second, is Cyberjar. And that makes a lot of sense, right? Because if you are a deck that plays Cyberjar like Panda Burn, it doesn't really matter if you go first. What matters is if you resolve Jar. So cards like this in Panda Burn, you might see down here that doesn't really matter whether they go first or second. Same with a lot of these cards that you might see in Reason Gate Turbo decks. And you still see a lot more burn decks cards here, like Secret Barrel, Limit Level Area B, Just Desserts. You see Dark Magician of Chaos in here. You see Brain Control in there. Obviously, Brain Control might be a card that you might legitimately think do better first than second. Hopefully, assuming that we're controlling for what card someone opened, but that's kind of what this chart is, okay? Best cards going first, best cards going second. The x-axis is the difference between the game win rate going first minus going second. And in parentheses is the actual card win rate for these cards. Okay, so just having that there as well. Ooh, cool. All right. So the best and worst cards pre-side. Okay, so the purpose of looking at best and worst cards pre-side is that we're going to follow up with post-side. I actually want to capture cards. I actually want to capture post-side cards and see their win rate, basically. So that makes sense in a moment. But let's first look at the best and worst cards pre-side. So best and worst cards pre-side. The best cards pre-side obviously is going to overlap with best cards in general. Pot of Greed, Charity, Donzalug. It's a pretty good card pre-side. Card Destruction is a good card pre-side. Pajama Trio, BLS, Rhoda, Barrel, Breaker, Panda. And then the worst cards pre-side. You got Mystic Tomato, Zaborg, Lightning Vortex, Dimension Fusion, Return, Brain Control. Just some bad cards in general. Okay, again, you gotta try to have the perspective in here that there's going to be other factors that have a lot of impact in placement of these cards. Okay, so looks good to me. Now we're going to go to the best and worst cards post side. Okay, so what we're going to see here is very similar cards to the pre side because Pot of Greed is good, pre side or post side. All right, cool. So we see Pot of Greed, we see Charity, we see card destruction post side. I actually expect this to increase from. So it's actually the same. So card destruction. So the reason that I'm doing post side is that I want to capture post side cards, as I've said. It doesn't quite do that just because like some cards are just good pre-side post side that you have a lot more samples for, which means the adjustment to the win rate would be less severe. So you won't actually see best cards post side and it'll be like a walk just because like this, again, look at this, right? The count, the samples are in the thousand. So, walk probably would be somewhere here, but unless you are filtering, unless you're doing analysis for a specific deck class, you're going to be just overwhelmed by cards that perform well in general with a lot more sample and all that. Okay. BLS, Duo, Dekoichi, Phoenix, Thunder Dragon, Sengen, Chaos, Sorcerer. And then the worst cards post side. You see, again, a lot more Earth stuff, and you see Panda stuff here, right? Earth and Panda stuff. These cards probably in general do worst post side, right? Cool. So not a lot from there, a lot of overlapping with the card analysis. All right, next one. Best cards pre-side versus post-side. So the reason that I have different sections for best and worst cards pre-side, post-side, and now pre-side versus post-side is because what pre-side versus post-side does, actually, let's read this. Unlike the past pre-side versus post-side charts, this one takes the same cards and measures its performance pre-side versus post-side. In other words, it's a card's pre-side win rate minus its post-side win rate. So what that means is the card has to be played both pre-side and post-side. It can't be something like a card that you'll side out often. It can't be a card that is post-side specific that you side in. Because if we're talking about walk, it's not really be here because no one main decks walk, right? You can't like compare the pre-side and post-side performance of walk if no one mains walk. It's just very different. So what this one is really trying to show is I don't recall actually, but we're gonna take a look. So the major difference is that in the previous charts, you would mostly just see good or bad cards in general. For example, Trinity being the common and best cards or basic cards from high win rate decks. Basic cards from high win rate decks meaning that cards for specific deck types like Chaos Turbo that have like a very good general win rate, you're going to see that up there pre-side and post-side just because those are Chaos Turbo specific cards, Phoenix, shit like that. Here, you would see which cards falls off the hardest post-side, okay? Here we go. So these cards cards with the biggest pre-side versus post-side win rate difference. This x-axis is the card game win rate difference between pre-side and post-side. So if we see a positive value, that means that these cards perform better pre-side and post-side. It's the pre-side win rate minus post-side win rate. So positive value, it does better pre-side. Negative value, it does better post-side. Okay, so performs, and these cards, of course, have to be played both pre-side and post-side. Okay, so you're not really going to see side-specific cards in here. Okay, so performs best pre-side, which I'm a trio. Barrel, Panda. You're going to see a lot of, some Warrior stuff, some Panda stuff, So these things is expected. These cards, that matchup performs better pre-side and post-side because post-side, they get slammed, right? Then we've got post-sides. Which one performs the best post-side? And we can see down here, we got Tomato, we got Zaborg, we got Dekoichi, Tsukiyomi, Jar Greed, we got Scapegoat, we got Break. All right, cool. All right, Chaos Turbo analysis. So we've done some analysis with matchups, we've done it with deck types, we've done it with games, we've done it with cards. All right. But the thing that has been kind of tricky is that whenever we look at top 10, bottom 10 of cards across matchups, we will see a lot of staples. We will see a lot of stuff that it's kind of noisy. So what we actually did here is I actually want to focus on one class here. And I also just wanted to do this because I also wanted to show what could be possible with this data. Because what I want you to do really is I'm making this public, right? Is the data is public, the repository is public. And so if y'all want to do something similar, answer some similar questions, you could look at, class by class analysis between deck types. All right, cool. So we're going to focus on Chaos Turbo here. So Chaos Turbo analysis, best and worst matchups. So first, let's make the base Chaos Turbo table. Okay, so don't worry about this. This is structuring data stuff. So now we're going to look at the best and worst matchups for Chaos Turbo. So Chaos Turbo's best and worst matchups. So their best matchup, number 1, Go Control. Number 2, Utter, Panda Burn, Zombie, Chaos Control, Earthbeat, Stein, Flipgate, Economics, Chaos Return. Cool. And just to kind of talk about Stein recently, PYST, don't know how to spell his name, don't know how to pronounce his name, did really well season 6 with Stein against his Stein deck against everything, but his Stein deck wouldn't classify as Steingate Turbo. Just wanted to mention, just clarify that. Okay. All right. Now for the worst matchups. Okay. So the very worst matchup down here. Yeah. So the worst matchup down here is Gearfried, and you can see that it's just a little sample, really. But you could confirm this with the matchup matrix, what the actual sample is, and what the win rate is for Gearfried. You know what? We can actually take a look at it because I'm kind of curious. So Chaos Turbo, Gearfried. So it's 4 out of 13. You know, so it's low, but the sample is definitely very low as well. All right. So you got Gearfried with a 13 sample. You got Reasoning Gate Turbo. Reasoning Gate Turbo definitely has more sample. We've seen it in the Matrix already, so I'm not going to bring that up again. Then we got Mataza Rush, probably same deal with most of these decks down here. But Drain Burn, Chaos Warrior Turbo, Relinquished, Cat OTK, Tomato. These are actually in the 50s now. So there's not a lot of matchups that is really tough for Chaos Turbo, basically, in aggregate across all seasons. Okay. There's not a lot that is a lot better. So you can see in bottom, like 10, you know, at a certain point, you start hitting the 50s. And now it's like, you know, a lot of these are also probably adjusted by the win rate as well. So have an adjusted win rate, you know, going towards 50 with low sample as well anyways. Okay? All right, cool. So that's the Chaos Turbo's best and worst matchups. All right, now best matchups pre-side versus post-side. So you can interpret this chart as which matchups are Chaos Turbo most prepared against. If the win rate is greater post-side, or if the win rate is greater pre-side, then poor, otherwise great. Let's check out the chart. Let's see what's going on there. All right. Chaos Turbo's best matchups pre-side versus post-side. The x-axis is the adjusted match win rate difference between pre-side and post-side. This probably is supposed to say game. Give me a second. Okay, so this is match win rate. This is for non-CT mirror. Oh, this is for non-mirror. All right. I'm actually going to ignore this chart. Can't recall how to interpret it, so we'll ignore that chart. All right, best and worst cards for Chaos Turbo. Okay, best and worst cards for Chaos Turbo. All right, so best and worst cards. We have our best cards. So Charity, you can see that it's kind of overthrown Pot of Greed, obviously, because Charity with Thunder Dragon, Serpent, Night Assailant, all that, it has a better win rate. So Graceful Charity, Pot of Greed, Breaker, BLS. This is why it's better than the best cards thing, because now we're actually looking within the Chaos Turbo class. And now you won't really see like Phoenix went blast up in here, card destruction went down a little bit. That's because the overall card win rate aggregation, looking at total stuff, since those cards are Chaos Turbo specific cards, and Chaos Turbo just has a good win rate across the board, those cards will just take precedence. Okay, but now within the class, we can actually see which cards tends to have a good win rate, I guess. So Charity Pot, Breaker, BLS, Duo, Card Destruction, Sangan, Book, Heavy Storm, Snatch, Steal. And then the worst cards. So we got Mind Control down here. We got Spirit Reaper. Is this game one? Let me check. Okay, no. So this is for all games. So this is pre-side and post-side. So you got Mind Control, you got Spirit Reaper, you got Zombira, you got and again, down here the worst cards, it kind of caps off where other than the Spirit Reaper. Now it's at 51%. So these are actually winning cards, but it's still ordered by the least. So you got Zombira, Kaiku, you got Mobius, Metamorphosis, Ruins, Cypher, No Mana Crossout, Short Priest. Now we're going to look at the best cards pre-side versus post-side. This is the same calculation that we looked at before. So these are cards performing. So this is the cards pre-side win rate minus their post-side win rate. So these cards have to be played pre-side and post-side And these difference, if it's positive, then that means the card does better in game 1 than post side. Okay. So the only card that does better pre-side than post-side is Phoenix. All right, performs better pre-side, Phoenix. Everything else seems to perform better post-side. All right, so we got Sangan Charity. Give me a second. So we got Sangan Charity BLS, card destruction, mind control. Um, all right, cool. I mean, I guess the idea was I wanted to see some cards that perform better post side, obviously. And you can see that the number one card here would be like Jar of Greed. And you got Break, Pot, Trap Dust Shoot. These things are kind of expected in the post side because Trap Dust Shoot, if you had Trap Dust Shoot in a bad matchup, you would set it out, right? But if you're keeping it, then it's a good matchup. And so it makes sense that it is a lot better post side because pre side, you got to keep it against Warriors and shit, but post side, probably really good. So you got Dust Shoot down here. And if you have a good post side, it makes sense to me as well that you have your draw cards be really good as well. So that's Pot of Greed, that's Jar of Greed, and Break is obviously just really good post side as well. So the post side stumped me a lot less than the pre-side. And the Sakura's armor, there's some cases where people, I guess, main Saku, so that's why it's here as well. Cool. All right. Well, this is that chart. Um, let's carry on. All right. So warrior matchup. All right, cool. So now we're gonna focus on the warrior matchup. All right, because we've noticed from the season 5 to 6 difference in the Chaos Turbo vs Warrior matchup, Warriors have recently improved by about 50 points. Okay, so let's take a look at warrior matchup, see what happened. So first and foremost, so first and foremost, for Chaos Turbo versus Warriors, for Chaos Turbo versus Warriors, here's the match win rates. So Chaos Turbo versus Warriors. Chaos Turbo has won across all seasons 363 matches out of 715 matches, with a normal win rate of 50.77 and adjusted win rate of 50.72. So, of course, at a high sample, the adjusted win rate is not going to make much of a difference to the win rate itself. So, it's about the same 50.7% win rate. Okay. So, this is overall Chaos Turbo versus Warriors. Okay. So, now we're going to look at the match win rates across the seasons. Okay. So now we got season 1, 2, 3, 4, 5, and 6. Okay. And the y-axis, we got the adjusted match win rate. And we can see that in season 1, season 6 looks dire, but apparently season 1, Chaos Turbo did a lot worse against Warriors than season 6. So season 1, Chaos Turbo did really bad, 43%. Season 2 is when I made those series of videos, if y'all recall. I made a series of videos about Chaos Turbo, and this is the stuff that I was trying to share with y'all. But you can see right up here that in season 2, the Chaos Turbo versus Warrior matchup is near 59%. It is tied with season 5 with being the highest win rate that Chaos Turbo has had against Warriors. Then you got season 3. It went kind of below this 50% match win rate thing. So you see it fluctuates a lot, right? So see you got 57 now, then you got 51, then you got 59 again, then you got 43. So it went back down again. So, recall when I was showing that chart with the season 6 and season 1 difference in win rate in Chaos Turbo versus Warriors, you can see that Chaos Turbo improved by like 1%. This is what you're seeing, right? Season 1, season 6, it says it improved, but like there's a whole bunch of fluctuation here. There's a lot of variance here throughout the seasons. So that's why I then narrowed it down to 5 and 6, because it's kind of the thing that I want to look at. Okay. But yeah, so the main thing that you would take away from here is that if you were to do analysis on this data, I would try to see what has changed from these peaks and from how it doesn't perform well down here. I'll probably pull all the cards. I'll probably pull their win rates. I'll probably try to do a regression on performance and try to see which cards is more a card's beta to the win rate or to a win of a match or game, and just look at the differences there. Okay, so this is the win rates across the seasons. Chaos Turbo versus Warriors. So now we're going to pull the game win rates. It's very common, very popular for people to say, or actually, it's well known. It is well known that Chaos Turbo versus Warriors, they have a bad game one win rate. They sacrifice game one a lot for the mirror. All right. But post side, they try to make up for that. Okay. They try to make it up post side. And that's typically the reasoning that Chaos Turbo has to neglect Warriors game one. All right. But let's actually see the numbers for this. So we got the game numbers 1, 2, and 3. I've actually filtered for less than 3, I think, yes. Because I'm not very interested in 4 and 5. The sample is low, anyways. So just to ensure that there's only game numbers between 1 and 3, I have the game numbers 1, 2, and 3, the wins during each of these game numbers, the count, and the adjusted match win rate. So you can see game 1, the adjusted match win rate is 42%. Right? So the win rate game 1 is 42%. All right. Game 2 is 55%. And then game 3 is about 51%. So y'all gotta look at this with the perspective that if you are losing game 1 more often than you're winning, then game 2, you're going to be going first more often than you're going second. And so when you see this this change of game win rate from 42 to 55, but then it goes back down again to 40 to 50 to 51, maybe like somewhere between 51 and 55 is the actual win rate for Chaos Turbo post side against Warriors in average, or not in average, but across all the seasons in total. All right. So that is the overall game number, Chaos Turbo win rate against Warriors. So now we're going to look at the same thing, game win rate across the seasons, and see if there's been any difference, right? Because I've been hearing a lot lately in season 6 that the game 1 win rate just went to hell, and that's the problem. It's not post side, it's pre side. It's game 1 that is a problem, not post side. So I actually want to see how these game win rates changed over time, and we could look especially at season 2, 5, and 6, because season 2 and 5 was from the best, season 6 the worst. Okay, so we can see here at season 1, they all have this pattern here, like this, up and down. So you could account for that with the going first stuff. So you can see here for season 1, performed the worst. Game 1 win rate was 40%, game 2, 55, then game 3, 43. So very abysmal. Season 2, game 1 win rate was about 48. So, weirdly enough, it was close to 50. So game 1 win rate was about close to 50. And then season 2, or rather in game 2 of season 2, it will then shoot up to 53. But then surprisingly, game 3 is 57. So game 3, you're going second, but you actually have a better win rate than going first with your post side. So that's kind of interesting. All right, season 3, same pattern. Season 4 is actually pretty interesting in the sense of it's game 3 here with game 2. Then you got season 5. Looks kind of similar to season 2, but I would say that season 5 had a much healthier post side because game 2 and game 3 are pretty even, I think, in this win rate. And game 1 also had a really good win rate as well, season 5. Imagine having a 50% win rate game 1. That's pretty good. So then season 6, where things went to hell, right? So you can see here that game 1 from the 50% in season 5, it went down 10 points. So the game 1 did get worse. But game 2, it also went down by a few points, by 5 points. But then game 3 went down also by 10 points, right? So across the board, game 1, 2, and 3, everything kind of went down. And so those are all areas that you got to kind of focus on. I think the moral of the story is that you probably do want a better game 1. Like you kind of want to have a game 1 that, I guess the TLDR is that I kind of want to mimic the performances here. And what I could tell from the performances here, the game 1 was at like a 50%, but you also need a healthy post side. I think those in combination definitely helps in producing those peaks that we've seen with the win rates across the seasons. Cool. All right. So now the game win rate pre-side versus post-side. Okay, so pre-side versus post-side. So this is not looking at just the game numbers anymore. Now we're looking at the actual pre-side and post-side. So just combining post-side together. And yes, and what we can see here is that pre-side, there's an adjusted win rate of 42%, about 43%. So across all the seasons, there's a pre-side win rate of 43%. But post-side, typically there's a win rate of 54%. Okay, so this is across the totals, pre-side, post-side. Cool. Cool. All right. So best and worst cards. So best and worst cards for Chaos Turbo versus Warriors. All right. So the best cards for Chaos Turbo versus Warriors. We got Charity. We got Pot of Greed. We got Charity. We got Heavy Storm. We got BLS, Breaker, Snatch, Mirror Force, Sakuretsu Armor, Duo, Card Destruction. And this is across all games. So this is game 1, post-side, pre-side, all that. And you got Card Destruction up here as well. Then you got the worst cards. No Mana Crossout, Mind Control. Kaiku is actually down here with Trap Doshu and Mind Control. Kaiku is similar to Trap Doshu, right? With hundreds of samples. So Trap Doshu, Spirit Reaper, Phoenix, Gorilla, Mobius, Assailant, Zambira, right? And worst cards obviously caps off at about 50% win rate here at Gorilla. So Gorilla is not losing, but you know, I don't think you're gaining much either with 50%. All right, cool. So we can see the best and worst cards against Warriors. Some things to note is that Charity went down from first to second. I could believe that in a Warrior matchup that plays a lot of dust shoots, plays solemn, shit like that. You know, stuff that, well, mostly the dust shoot, I would say. Dust shoot and maybe Donzaloo, stuff like that. Whereas Pot of Greed, you don't really need much conditions to make it work. You kind of just slam it and things will work out. Okay, so we also see Card Destruction over here for best cards, 54%. So again, this is game 1, game 2, game 3, and Card Destruction is here against Warriors. So good to know. Great. So best and worst cards, pre-side. Okay, we're gonna look at pre-side cards now. So best cards, pre-side. So we got Charity Pot. All right, cool. So we got Charity Pot, we got Card Destruction. So Card Destruction, I mean, the pre-side win rate is pretty bad anyways, but they have a 52% win rate, or a 50 and up percent win rate from Snatch Steal to Charity. And we got Charity Pot and Card Destruction. You know, it's kind of interesting that Duo is so far down, too, by the way. You know, Duo, obviously Warrior can sit their hand and everything, depending on who goes first and second, so that's obviously a factor. But yeah, we know what the best cards seem to be pre-side versus Warriors. So Card Destruction is actually up here against Warriors, so that's good. You got BLS, Heavy Storm, Mirror Force, Breaker, Snatch, Ring, Duo. Cool. Now we got the worst cards, pre-side. So no Mana Crossout, obviously. Surprisingly, Tsukiyomi was here. In my opinion, obviously Control is a big factor. Control is a huge factor, matter of fact. But Warriors was also a big factor for Tsukiyomi for me in my main deck. So it's kind of interesting to see Tsukiyomi down here with no Mana Crossout. For the worst cards pre-side. Matter of fact, Trap Dust Shoot is not even on here. You know, people I think exaggerates Dust Shoot against. I mean, obviously it depends on who goes first. Depends on who goes first. You know, but anyways, but Dust Shoot is not on here actually, so that's kind of surprising I think. So you got yeah, I mean you got Thunder Dragon down here. I mean that's probably just a matter of. I'm not even gonna say it, but it's interesting. So you got Break, Greed, the Koichi, obviously some of your flips. It's pretty bad pre-side. Like for instance, the Spy is not much better than the Koichi pre-side, just because they're out to stuff without Sakuretsu's whatever. It doesn't even really matter. So that's kind of interesting. And you got Thunder Dragon, Night Assailant. Night Assailant doing better than these cards probably because of its ceiling. With the discard traps, with CD, Tribe, and all that. So Phoenix, Wind Blast is up there, and then you got Fate as well. All right, cool. So now best and worst cards post-side. So here I'm trying to capture post-side specific cards. Okay, so here are the best cards post-side. Pot of Greed, Charity, Heavy Storm, BLS, Snatch, Breaker, Dekoichi, Tribe, Duo, Mirror Force. All right, best cards post-side. Now we got the worst cards post-side. So we got Kaiku. And now, no, granted, the cap for 50% win right here ends kind of quickly. So usually the cards that people keep post-side against the Warrior matchup is not like a bad decision, except for like the people who keeps no Mana Crossout against Warriors because they've seen, flips or something. That is typically not a great idea. Likewise for Kaiku, likewise for Phoenix. But you actually got Card Destruction down here as well. But it's 53%, so it's not the end of the world. All right, so you got Card Destruction down here. You got Solemn a bit higher. You got Tsukiyomi doing better post-side. So I guess what I'm kind of seeing here is that Obviously, individually, these cards, we're trying to look at individual win rates of cards when we have a median, partial deck of what, 40%. So 40%, like about 17, 18 of cards are seen per game. It's a lot more cards than just one Tsukiyomi. So there's a lot of things, there's a lot of factors, I guess, going into play here, where if your deck is just bad pre-side, but better post-side, some things, it's just some factors to keep in mind of. All right. So Tsukiyomi, Night Salient, Torrential is down here. You got Book of Moon is also down here, but again, this is like in the 50s anyway. So these are all positive. Okay. All right, cool. Actually, as a matter of fact, we got to recall here that the pre-side and post-side win rate. So the post-side win rate is actually 53%. This is your benchmark. So if you're outperforming your benchmark post-side, then I think there's actually signal in there. But for these to be either so below 53%, like these cards, or kind of negligible, I think that these cards probably just are not as impactful as people say they are. All right. I think for these to be good win rates, like good as in greater than 50, is probably being overshadowed by just the fact that these have really good post-side win rate, probably thanks to some of the skew in these cards. But something to note is that I'm not seeing some of the other side deck cards in here. Like I'm not seeing Sakuretsu in here. I'm not seeing beaters in here. So just something to note. These top 10 cards are all still like cards that people main. Okay. All right. So now best cards pre-side versus post-side. So y'all remember how this works. Pretty much the card has to be in both pre-side and post-side. So we won't see any post-side specific cards in here unless someone has mained it. Possible in the War League. But let's check this out. So these cards perform better pre-side. So no card performed better pre-side. No card performed better pre-side. The only one that's kind of negligible pre-side with post-side is card destruction, which makes sense because its post-side win rate is not very high either, right? So the difference between pre-side and post-side is probably not much different. Okay, so we got Kaiku as well down here, performs better pre-side. Nobleman performs better pre-side. That's hilarious. So this thing goes down. Oh, actually, give me a second. Yes. Goes down. Okay, yeah. So that is the order of things. Okay. So these cards perform better, or rather, if the card is positive, if the value here is positive, then it would perform better pre-side. But every card here performs better post-side. So there's actually no card that performs better pre-side than post-side because we have no positive numbers here for the difference between pre-side and post-side. But in order, like relatively speaking, these cards up here performs better pre-side than these cards. So that's kind of how you interpret this. Okay. So cool. Ring, Solemn, Torrential, Mirror Forest, Book. Then you got cards that performs better post-side. So it starts here. So Pot of Greed actually performs a lot better post-side than pre-side. And that's probably because pre-side you have a really bad win rate, right? And the cards that you would draw pre-side are probably not very good anyways. Whereas post-side, if you have a really good post-side, then your draw cards are going to be quite good, right? So you have Pot of Greed as the number one card that improves the most from pre-side to post-side. And that's probably because you're just drawing better cards. It's a lot more impactful of the card, stuff like that. Likewise with Draw Greed. You see it up here as well. Break performs a lot better post-side. Dekoichi, Tribe, Thunder Dragon, Spy, Fate, so on and so forth. All right, cool. So now let's get kind of specific. What changed between Season 5 and 6? All right, so we're going to look at Chaos Turbo's post-side cards performance differences. All right, so I kind of shared this a bit in the Go Hub. This is also our last chart. All right, this video kind of went on a bit. I ain't gonna lie. It might be the longest video, actually. But Chaos Turbo vs. Warriors, Season 5 vs. 6 post-side cards. So what this is showing, recall that we have the post-side win rates of cards, right? Post-side win rates, game greater than game 1. We have the post-side win rates of cards, Season 5 and 6 for the matchup of Chaos Turbo versus Warriors. Post-side win rate. I have the post-side win rate of these cards for Season 5 and 6. What this thing is doing is that it is taking the season 6 post side win rate and subtracting it from season 5 post side win rate. So if you were to see a positive value here, that means that a card performed a lot better in season 6 than it did season 5. All right, that's how you interpret this. And if you see a negative number, then the card fell off. The card performed a lot better in season 5 than it did season 6. So let's look at this. So post side cards that fell off. So the most negative number means that these cards were a lot better season 5 post side. So the number one card down here that fell off the most was Pot of Greed. Back in season 6, Pot of Greed was a very impactful card. You use that card, you're very likely to win. But in season 6, it doesn't even really matter what card you see. It doesn't even really matter if you see Pot of Greed. Just because the win rate, the match was probably just really bad. So it is just it's not to say that this means that Pot of Greed wouldn't have the highest card post side win rate. That's not what it means. We know that Pot of Greed has the highest post side win rate. What it means is that the difference in his performance or in his win rate season 6 season 5 versus season 6 went down a lot. This card used to be a lot more impactful. All right. So it started with a very high pedestal. It started at a very high standard of being like maybe an auto win at season 6, whereas now it is a lot less impactful. Okay. So that's what we see Pot of Greed down here. Then we see Sakuretsu Armor. Sakuretsu fell off really hard. All right. Ring of Destruction, Break, Solemn, Thunder Dragon, Spy, Breaker, Heavy Storm, Jar Greed. What I see when I see this here, these are all traps, right? Sakuretsu, Ring, Break, Solemn. If you know about how Warriors are starting to side for Chaos Turbo, you're starting to see a lot more hate for Spell and Traps. You know that Moxie's is out there trying to do Zings, right? So, you see side decks now doing like 1 or 2 copies of Zings in the side deck. I've also seen another player, Enrico, that has been playing Bandit in their side deck, right? So when people are playing the Spell and Trap hate, you wouldn't really win the war there with your traps as Chaos Turbo versus Warriors, because Warriors, especially when they start throwing in cards like Zing or Green Kappa, these cards are going to plus on you. They're going to plus on you, and once those things are traded, say you try to trade and you go and you trade down, you're still left with flips. You have these flips, and the Warrior players, they have their monsters that are just going to trample over them, and they're going to plus. That's how I've seen that they've been winning, and I kind of see that reflected here because the traps are not doing as good as it used to do. These traps used to be a lot more impactful season 6. Okay, I agree. Okay, so post side cards that got better. So we can see here, number 1 here, Metamorphosis got better. So season 5, Metamorphosis wasn't as good as it is in season 6. So you could probably, so that's what it means. Metamorphosis. So Control Smokes, they got better post side season 6. All right. Then you got Dust Tornado. You got Card Destruction. It's doing better post side. And that makes sense because Warrior players, they're starting to side out their Card Destructions in the Chaos Turbo matchup because, one of the main strategies with the Chaos Turbo decks, especially when it's side in Solemns and stuff, is that they try to make Dust Shoot dead. And so what they would do is that they would set a lot of the cards, especially when they're going second. They'll set like all their hands sometimes, with Solemns, Sakuretsu, Jar Greeds, and Breaks. So when they start siding out their Dust Shoots to focus more on the field by, instead of placing it with like Zings, then, all of a sudden they have these outs to the traps and they could trap over the flips. But that also is an area where Card Destruction shines a bit more, because if Card Destruction is not in the picture, then Card Destruction is a lot more consistent, right? So you got Metamorphosis, Tornado, Card Destruction, and Triumph. These are the only cards that have gotten better post side. Everywhere else, you gotta look kind of look at it relatively speaking. They all still got kind of worse. So you got Charity, Night Assailant. It makes sense that in order it is up here in the top 10 because of its relationship with Card Destruction. And then you see Mirror Force, Tribute, Nobleman, Crossout, and then Scapegoat. I think one thing more to mention here is that with Metamorphosis and Scapegoat, with the difference that it has, I think too much people value Scapegoat of itself, Scapegoat alone against Warriors. I think that's ass. All right. When you see Scapegoat, Scapegoat did worse, season 5 to 6. All right, it's a negative number. When you see Scapegoat and you activate it in your post side, you're going to have flips, right? You might have Fate, you might have Spy, right? So when you have this post side of flips and you have scapegoat, and say you're citing out like a third copy of Sakuretsu, or you're citing out other safer monsters to set out there, like maybe a Zambara or some kind of set monster to put out there. When you're citing in scapegoat and you think that card is good alone versus warriors, you're tripping. You want to know why? Because you use that card and they're just going to attack over it, and they're going to, it could be a card that could protect your flip, basically. That's the main thing. People talk about saving turns. You're saving turns, right? Like I'm preventing some damage, but you're losing your control of the field. All right. If you lose your control on the field, like over time, you're avoiding like maybe 3,000, life points of damage, whatever. But the opponent has all these monsters on field. You can't put any of your flips down. You know what I'm saying? Because they could have that level 2. They could have that Sasuke. And if your position is losing, then all what you really have done is you've drawn a few cards, but you're neg 1, and your position is losing. So scapegoat, it makes sense to me that it is not at the same level here as metamorphosis. What really matters is whether or not you resolve metamorphosis. And the reason why metamorphosis is up here at like a 6-point difference from scapegoat is that metamorphosis by itself is actually better, has actually performed better than scapegoat by itself, right? Cool. So that's very interesting. And that's the end. Okay, so there's all kind of shit you could do with this data. Let me be here. So there's all kind of shit you could do with this data. I made it public. It's in the description, and that's it. All right, that's the end. That's a long video. Let me actually see the recording on this. Wow, crazy. Okay, 2 hours in. So this is the end. I'm gonna wrap it up. This is the last video of this series. So if y'all stuck around, thanks. Again, I just want to recap. I'm gonna have to re-record the intro because now that I have a better idea of how shit is gonna go down, I kind of want to prepare y'all, those who are technical and non-technical, what to expect. And that's the end. So I'm gonna wrap this up now. And one more thing, Kev, it's time to come back home. All right, catch y'all next time.